Now, before we get started on today's assignment or lesson, are there any questions over the assignment? So, guys, make sure that you did take one because there are exactly 19. So 951.
Yes, 951.
Which one?
1.
Number 3?
Number 7.
Okay, I was trying to see which one you wanted
Yeah.
because we didn't do 1. Number 7. 951. So it wants us to find sine of F, B, and E. So it wants us to find sine and cosine of angles D and E. And just as a reminder, sine of an angle is equal to the opposite side length over the hypotenuse. And cosine of a given angle is going to be adjacent over the hypotenuse. So sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So here it wants us to find sine of angle D. Well, the side opposite angle D is square root of 3. The hypotenuse is 26. And cosine of angle D would be the adjacent side, which is 13, and the hypotenuse is still 26. Now, did want us to find it as a fraction and as a decimal. So on the calculator, we can do 13 seconds square root 3 over 26, which is square root 3 over 2, or 0.8660. We can also do 13 over 26, which is 1/2. Now we need to do the same thing for angle E, so sine of angle E, the opposite side is 13, and the hypotenuse is still 26, which as a decimal would be 0.5000. And cosine of angle E is going to be 13 square root 3 over 26, because the adjacent side to angle E
Yeah, I know. I remember that from stuff.
and that is it there. Any other questions on this here? Okay. First thing we're going to look at is finding the value of for sine and cosine. Now, specifically, originally, the way that you would find sine of 62 degrees is you would pull up a sine, cosine, and tangent chart and look for that given angle in the table. Now, for us, we can use the calculator. Now, you do need to make sure that the top of it does say degrees DEG, because everything we'll be doing in here is going to be in degrees. So when it's asking us to find sine of 62 degrees, we can take the calculator and say sine 62 and hit enter. It should just say DEG. 0.8829. Yeah, so sine of 62 degrees does have a specific value, and it's 0.8829, and it continues on. We can do the same with sine of 14. So we say sine of 14 degrees is 0.241921896, or 0.2419. And the same is true for cosine. So we can take cosine of 60 degrees, which is 1/2, or 0.5. Either one of these here, because some of the trigonometric functions, sine, cosine, and tangent, will have nice values. Some will not. We could also say cosine of 31 degrees, 0.8571. 72. Round up. If the number after it's 5 or greater, we round to the one it's closest to. So 1/6 is closer to 2 than it is to 0. So 0.8572 if we round it. But sine, cosine, and tangent of a given angle actually does have a value. Questions on this so far? We good with this here so far? Yes? Now, we can use this to actually evaluate for sides, side lengths. Because we're given 26 degrees here, and we want to find x and y. Now, sine of 26 degrees. Sine is what over what? The opposite side length over the hypotenuse. So what's the opposite side of 26 degrees? The opposite side would be, and the hypotenuse is 14. So sine of 26 degrees is equal to x over 14, opposite over the hypotenuse. Well, we could solve this here, because sine of 26 degrees, as we just saw a minute ago, actually does have a value. It has a number value. So if we wanted to solve this, well, the first thing we can do is multiply both sides by 14. Here, these would cancel, telling us x is equal to 14 sine of 26. Any questions on this so far? Now at this point here, we do need to evaluate 14 sine of 26, and they want us to round to the nearest tenth. So we can take the calculator and say 14 sine of 26 degrees. And we get 6.137, or rounded to the nearest tenth is 6.1. Yeah, it multiplied it. It multiplied it. It took the value of sine of 26 and multiplied it by 14. Now, that gave us the opposite side and the hypotenuse. If we took cosine of 26 degrees, well, cosine is what over what? Adjacent over the hypotenuse. So the adjacent side to this angle is, and the hypotenuse is 14. This point here, we would, again, multiply both sides by 14 to get y by itself. Because here the 14 and 14 will. And here, y is going to equal 14 cosine of 26. And let's see what we get. 14 cosine of 26 is 12.6. Now, using sine and cosine, it's going to depend on what we're given, because sine is of an angle is equal to the opposite side over the hypotenuse. Cosine of a given angle is adjacent over the hypotenuse. So if we're from a given angle, if we're given the side opposite in the hypotenuse, we'll use sine. If we're given adjacent in the hypotenuse, we will use cosine. So depending on what side we have, or what sides we have, and what sides we're solving for, will depend on if we use sine or cosine. Questions on this here? So if we look at this here, we want to find the values of u and t using 65 degrees. So sine or cosine, which one would we use to solve for t? So t is next to or away from. So sine of 65 degrees would give us the opposite side t over the hypotenuse, which is 8. Cosine of 65 would be used to solve for which one? U, because it'd be u over 8. Now here we're wanting to solve for both u and t, so we could use both to get there. Now if we're solving for sine first, the first thing we'll need to do is multiply both sides by 8. And really, no matter which side we solve for, we'll multiply by whatever's on the bottom of this fraction for these setups here, because here the 8 and 8 will cancel, telling us that t is equal to 8 sine of 65 degrees. Is the variable by itself? Yeah, t is by itself, so 8 sine of 65, 8 sine of 65 degrees is 7.25, or rounded to the nearest tenth would be 7.3. Now what would we do for cosine? First step would be to multiply both sides by 8. Because here the 8 and 8 would cancel, leaving us with u by itself is equal to 8 cosine of. Yes. No, you're good. And if we plug it in, we would get 3.4. Questions on this here? Would we expect the value of t or u for this problem here to be bigger than 8? No, because 8 is what? The hypotenuse. Hypotenuse is always the longest side. Any questions on any of this here? So looking at this one here, so we're going to solve for x and y. Let's solve for x first. How would we set it up if we want to solve for the value of x?
X over 35, right?
So sine of 35, sine of our angle.
And then it would be X.
Opposite side over the hypotenuse. Sine of a given angle is equal to the opposite side over the hypotenuse. What would we do next? We're going to multiply both sides by 53. Which will tell us that here these will cancel, giving us x by itself is equal to 53 sine of 35. And again, we can plug in the calculator. 53 sine of 35 is 30.39, so 30.4.
Do we have to round it up when we do it?
If it asks for it. Because I think for these here, it's asking us to round to the nearest tenth. Now, if we wanted to find y using sine and cosine, we would say of 35 degrees is equal to adjacent side, which is y, because y is right next to the 35, so it's the adjacent, and the hypotenuse is 53, because it's opposite the right angle. But again, we're going to multiply both sides by 53, telling us that y is equal to 53 cosine of 23.4. So we have the one side as 30.4 and the other as 43.4. Well, if we solve for it, the other angle would be 65 degrees. So we do expect that one to be bigger. Bigger side's opposite the bigger angle. Smaller side is opposite the smaller angle. Any questions over any of this here? So it shouldn't be 65, it should be 55. Questions? Are we ready for the next one? How do we feel about most of these here? Feel good with these here? So let's look at this one here. So if we're using 30 degrees, now, so x is adjacent to the 30 degrees, yes? And y is the hypotenuse. So if I use cosine of 30 degrees, we would have what over what? So if we do cosine of 30 degrees, we get x over y, yes? Well, we can't solve for two variables at the same time. So what's sine of 30 degrees going to be? The opposite side is 20, and the hypotenuse is y. So we can solve this one here first. So what can we do first? We would multiply both sides by? We multiply by the bottom of the fraction, because y and y, these will cancel. It tells us that we have y times sine of 30 is equal to 20. Because 20y divided by y is 20. Now, what do we know about sine of 30? Sine of 30 is just a number, yes? Yes, but not quite. Not because y and sine are being what? Added or multiplied? So to undo multiplication, we would. So we're going to divide by. Yes. It is indeed 40. So in the calculator, we do fraction 20 over sine of 30, which is 40. So we now know what the hypotenuse is, yes? So over here, we can replace y with yes. and we multiply by 40, we get x is equal to 40. Yes. Now, we can plug it in at this point because the variable is by itself. The other one we had to divide by sign because here y was not by itself. And that's it. That's all we have to do for these here. So this one here was a little bit different because they didn't give us the hypotenuse like on the first few. When we're given the hypotenuse, they do work out a little bit easier. But the only thing that we add to it when we're solving for the hypotenuse is we have to divide by sine at the given angle. Any questions on this here? Let's look at one more, especially one where we're having to find the hypotenuse as one of our sides. So here, x is the hypotenuse. So which one can we solve for first, or using first, sine or cosine? So sine of 51 degrees is what over what? Opposite side would be? Because the opposite side of 51 is y. Yes. Because cosine of 51 degrees is the adjacent side, and the side adjacent to 51 degrees is, and the hypotenuse is still x. Because depending on which one we want to use, we look at the angle and then see, do we have the side opposite in hypotenuse or adjacent in hypotenuse? Now, the first thing we're going to do is multiply both sides by the bottom of the fraction. And the bottom of this fraction is x. And the reason that we do this is this side is going to be x cosine of 51. If we wrote this out, when we multiply the x by the numerator, which would give us 10x divided by x. But x divided by x is, anything divided by itself is 1. Yeah, they cancel each other out. Is x by itself? Yes, on both sides. Because here these will simplify out. And the calculator, we can do 10 over cosine of 51, which is 15.89, or we can say 15 point. Now that we do have the value of x, we can plug it in. Sine of 51 degrees is equal to y over 15.9. What would we do first here? Multiply both sides by 15.9. As these two here will cancel. Telling us y is equal to 15.9 times sine of 51. $12.35, or yes, 12.4. Questions on this here? We good with this here so far? Yes. Okay, that's fine. You're good? Will sine or cosine for our right angles or our right triangles have a value greater than 1? Well, this for a right triangle, will sine's value of a given angle be greater than 1? Because sine of a given angle is what? The opposite side over the hypotenuse, yes? No, this is just a side note. Because we're doing the opposite side over the hypotenuse. The hypotenuse is always what? The hypotenuse is always the biggest side. So for what we're doing this here, can sine of A ever give us a value greater than 1? Can this, for what we're doing, be greater than 1? Because here, opposite side over the hypotenuse is always what? The biggest side, yes? To be bigger than 1, what side has to be bigger? So guys, let's focus in here for a second. So this here, greater than 1. For this to be greater than 1, for a fraction to be greater than 1, which has to be bigger? The top of the fraction or the bottom? Hypotenuse is always greater. But for this to be 2, which one has to be bigger, the opposite side or the hypotenuse? The opposite, yes? Will the opposite side ever be bigger than the hypotenuse? So could this ever be greater than 1? No. It actually works out for sine, cosine, and tangent. The sine, cosine, tangent functions, they're never greater than 1 or less than negative 1. They're always contained there. So here, sine of 53 would be what over what? Opposite would be, and the hypotenuse is y. So we can't use sine first, but cosine of 53 is what over what? Adjacent, which is 12 over y. You can follow along if you want. Yeah. So we multiply by 53. We get y times 53. Cosine of 53 is equal to 12. But to get y by itself, we would divide both sides by cosine of 53. These will cancel, giving us y by itself. 12 divided by cosine of 53 is 19.93 or 19.9. Multiply both sides by 19.9. Minus x is equal to 19.9 sine of 53. $15.9. Yep. Any questions on any of this here? Okay. Now we're going to do one last problem, and then we're done for the day. Angle of depression and angle of elevation. Angle of elevation is an angle formed from sight line going up, so elevation. Angle of depression is the downward line of sight that makes with the horizontal. So if we looked at this here would be considered the angle of depression because it's going down from horizontal looking down. Now this angle over here would be considered the angle of elevation. And the angle of depression and the angle of elevation are actually the same. Because here they're looking down at 21 degrees. Here, And we can use this angle of depression or angle of elevation with a few more pieces of information to find a missing side. So here we're finding the value of x. Now from the given angle and what we're given here, so we're finding the hypotenuse. Now 21 degrees and 1200 feet, are they opposite or adjacent? So would we use sine or cosine? Because sine of 21 degrees, the opposite divided by the hypotenuse, which would be x.
I have a question.
Yes.
So this side is 1,200 feet. Will that side be 1,200 feet?
Yes.
I don't
Yes.
know. It may be 1,201 feet.
It will be 1,200 feet. So it would be 1,200 feet. Now to solve, the first thing we would need to do is multiply both sides by, so that these will cancel. Telling us x, guys, almost there. 21 is equal to 1,200. Then we would divide by sine of 21. Over 3348.5. So the distance that the skier is going to go is 3,348.5 feet. 5,280. 5.4 or 5. Well, since it wants actually to the nearest foot, it would be 3,349
What's that?
feet.
Oh, that's feet. Okay.
So, guys,
Can we go, or can I help Jessica take down the flag?
yes.